Hello and welcome. Up to now, we've created tables, forms, menu items, and even placed our feature into the main menu. So visually, everything looks complete. Users can open forms. They can click buttons. They can even open dialogues. But right now, the system is very polite. It accepts everything without asking questions. And that's because we haven't added any business logic yet. This is where classes come in. Classes are where the system starts thinking. In simple terms, classes are where we write business logic. Forms are for interaction. Tables are for storage. Classes are for decisions. Now it's time to actually build one. In this video, we'll design a clean, structured class to create a new leave request. No shortcuts. No logic inside forms. And no surprises later. We'll focus on structure, responsibility, and extensibility. So the code behaves well today and still behaves well after someone else touches it. Let's get started. Now let's move into the actual class design for creating a new leave request. What I'll demonstrate here is a class responsible only for creating a leave request. One class. One responsibility. Let's start from the top. The first thing we create is a new method. This method will be protected. Why protected? Because this follows Microsoft best practices. We don't want anyone randomly creating objects without going through the intended flow. So creation is controlled. Now next comes the construct method. At this point, these methods are still empty. So the next question is important. What inputs do we actually need to create a leave request? Let's think logically. We need employee ID, leave type, from date, to date, reason. That's it. No magic. No extra fields. So we declare global variables for these inputs. And very importantly, we do not use base types like string or date. We use the extended data types we created earlier. Because meaning matters. An employee ID is not just a string. A leave from date is not just a date. Now let's talk about variable access. All global variables will be private. This is a practice I personally follow. Private variables protect the internal state of the class. No one outside the class should directly modify them. If someone wants access, they must go through methods. This gives us control, validation points, and flexibility. Now, how do we expose these values? Since these values are set only once, during object creation, we don't need setter methods everywhere. So I create get methods for each variable. If a variable ever needs both get and set, I would use a parm method. But here, values are set only in the beginning, so get methods are enough. This approach has advantages. It keeps the class immutable after creation. It avoids accidental data changes. And it makes debugging much easier. Next comes the most important part. Creating the leave request. For that, we create a public method called create, and I intentionally keep this method name simple. Because the class name already explains what we're doing. Seeing something like create new leave request. Create new leave request is just duplicate information. The class name provides context. The method performs the action. Now here's an important design rule. The create method contains no actual logic. Instead, it defines the flow. First, validation. Then execution. So inside create, the first call is to a method called canCreate. This method checks whether creation is allowed. Date's valid. Employee exists. Anything else you want to validate? Then, to support extensibility, I add two more methods. Pre-create and post-create. These methods are protected. This allows other developers to extend the class and add behavior before or after creation, without touching core logic. This is extremely important in real projects. Now comes the actual logic. That logic lives in a method called doCreate. This method is private. Because this is the heart of the class. No one should override it. No one should modify it. If logic needs to change, we change it here, intentionally. Inside doCreate, we have two responsibilities. First, initialize a new record in the leave request table. Second, insert it. To follow single responsibility principle, I split these into two methods. One method initializes the record using global variables. Another method simply inserts the record. Clean. Readable. Maintainable. And now the class is complete. All inputs are controlled. Logic is protected. Extension points exist. Responsibilities are clearly separated. Now we update the new method and the construct method. Both methods take the same set of parameters. Employee ID, leave type, from date to date, and reason. Inside the new method, we assign these parameters to the private global variables. So now the class has all the input it needs. Finally, this class will be called from the OK button of the new leave request dialog. The form will construct the class, call the create method, and that's it. The form doesn't decide anything. The class does. And that's how business logic should be written. In the next step, we'll start adding actual validation logic and see this class in action. And yes, this structure might look a little long now. But future you will be very grateful for it. Now that our class is ready, let's see it in action. First, we build the solution. Once the build is successful, we reload the application in the browser. Now go to the Leave Management module. Open Leave Requests. On the top, click New Leave Request. This opens our dialog, the same one we wired earlier. Now let's fill in the details. Select the employee ID. Choose the leave type. Enter the from date and to date. And for the reason, let's keep it honest. Something like, personal maintenance required. Now click OK. Behind the scenes, the form calls our class. The class validates the input, initializes the record, and inserts the leave request. And just like that, a new leave request is created. No logic in the form. No direct table inserts. Just clean flow, exactly as designed. If something goes wrong later, we know exactly where to look. And that's the real win. So in this video, we designed a class to create leave requests the right way. We controlled object creation, protected internal state, separated validation from execution, and added extension points without exposing core logic. The form simply triggers the action. The class does the thinking. This may feel like extra effort now, but this structure saves hours when requirements change. And they always change. In the next video, we'll start adding actual validation logic and see how this class behaves in real scenarios. Thanks for watching. And remember, good class design is invisible when it works, and painfully obvious when it doesn't.